Welcome to part two of week 12, Introduction to C++, and we are covering object-oriented programming, or OOP, and classes and objects. And I want to start this off with a question, and I want to hear what you guys say now before we get into it, and then I'll try to ask the same question if I remember at the very end of this video. What is the difference between an object and a class? Think about that. An object and a class. What's the difference between them? They're different things. Do you know the difference? Try to explain it to me here in chat or in the comments. And then I'll just kind of talk about the speed we're going to go through today. So we're going to talk about classes and objects, obviously, and what object-oriented programming is, why we want to use it. I am assuming in this video that you guys know the concept of classes and objects in other programming languages. So we'll go a little bit quicker than we normally would, which will allow us to just kind of introduce you to the syntax of C++. These slides do have a lot of information on what classes and objects are if you've never heard of them, but I'll probably be going a little quicker. So if you need to pause or play it back, then totally do that. Download the slides from Blackboard. We're going to be talking about constructors, deconstructors, or destructors, which is a new concept, I guess, for some of you. So we'll talk about that in a bit more depth, and public and private access modifiers. So you think an object is a broader term that's comprising of classes. You're onto something there. Okay. You consider an object as a behavior. Okay, that's a pretty abstract way of thinking about it, but you're onto it. Like it's kind of the idea of what I'm looking for. To illustrate creatures on Earth would be an object in animals and humans. Okay. Um, okay, sorry. Creatures on Earth would be an object, and animals and humans are classes. Is that what you're saying? Objects get their traits from classes. There it is, Raymond. Perfect. So that's what I'm looking for. So you guys kind of were getting there with the abstract thinking of it, saying like it's a broader term that comprises of a class. Or another really easy way to say it is an object is an instance of a class. So if we think about it, and I was thinking really hard of what a good example of this was, and I couldn't really come up with something to like visualize other than maybe if I annotate on here. I was going to use my whiteboard, but it's super messy right now. So if I tried to annotate on this slide, I don't know why my screen always disappears when I do this. My goodness, WebEx is causing some issues for me today. Okay. I don't know. Can you see my drawing? Let me try to retry this. Annotate. Okay. All right. I want you to hold that thought there. So now I can draw. So an object gets its trait from a class. So this was the example that I thought of. So it's basically a template. A class is a template, right? A class is, let's say we're going to the gym to work out, and you want to become a member of that gym, of LA Fitness or something like that. And they have these forms for you to fill out to become a member, okay? And that form looks something like this. This is going to be a really crude drawing because my mouse skills are not on point today. They want your name, right? And let's say we'll leave a line for name, and they want your, I don't know, your phone number. So I'll just put num and leave a spot like that. Now this form, okay, can be photocopied thousands and thousands of times, okay? And we can make copies of it or instances of it. And then once I fill it out, okay, over here and say I'm coming to the gym, I'm filling it out, and I put my name as Ben, and my number was, I don't know, 734 or something, whatever I can fit in there, then now all of a sudden I've got something that's an instance of this form that's been, you know, a template sort of thing. So this template can be copied a bunch of times down here like this, and then you can fill it out with specific properties and details as an instance or an object of that class. So this would be your object, right? It's still the same form. So here you have like your member form, right? Member. And here, this is also still a member, but it's not the template, right? It's not empty. It has properties and values, and it's an instance, or it has all its traits from the class. So exactly, Raymond, you had it. Perfect. It's just an interesting question. Some people don't understand or have that concept in their head, like a class is a template that we create, and objects are instances that we create them out of. Okay, cool. So let's move on and talk about what we're going to talk about today. So we've actually done some object-oriented programming in C++ already using the string and the vector class, because those are class templates that we create objects of. But I'm going to show you how to make our own today. So we're going to talk about what OOP is, what a class and an object is, which I know you guys already know, so I'll go quickly. We'll talk about dot and pointer operators, as well as public and private access modifiers, so information hiding and encapsulation, which you may know what the concepts are, but knowing the name that goes with them is also really good, and it's a powerful thing to do, because then when you're talking in the workplace, you can use the right terminology. So we'll define these concepts in C++. And then we're going to talk about methods, constructors, and destructors, which I know those are a little bit new, so I'll spend a bit more time on that slide. Class methods, default, and overloaded constructors, which, you know, overloading you guys have had experience with before, I've heard. Copying and moving, shallow versus deep copy, right? This concept of shallow versus deep copying, by default, C++ provides shallow copying, right? But sometimes we need to do more than that, and we'll learn how and why. So don't worry about that too much. We'll talk about that probably next week when we get into it a little bit more in depth. And then static class members. Sometimes when we write object-oriented programs, we want certain attributes to belong to the entire class and not to the object themselves. So that's what a static class member allows us to do. And then the friend of a class and struct versus class. Those are also maybe new concepts for you guys that we'll probably get into more detail next week. So we'll get all of the stuff and the syntax and you know, things that you do understand out of the way so that you're comfortable with it, and then we'll kind of build on that as we go. Cool. So what is object-oriented programming? Feel free to tell me. What do you guys believe object-oriented programming is? So far in this course, what we've been doing is called procedural programming, which is different than object-oriented programming. Procedural programming is where you're focusing on the process or the actions that typically, you know, there's a collection of functions and there's data that's declared separately and it's passed into arguments as functions. It's pretty easy. It's easy to understand. It's a procedure, right? And you have an order to what's happening. There's a ton of limitations on these. First of all, your functions need to know the structure of the data. So as the program gets larger, it's really difficult to understand. It's really difficult to maintain. It's difficult to extend upon it. If you're everything in one class, it's difficult to debug or to reuse code because it's all over the place. And it's all in, by all over the place, I mean it's all in one file, but who knows where it is. You'd have to scroll forever trying to find a certain method. And it's really easy to break because it's not modularized, right? So what I said here, functions need to know the structure of their data. Well, what I mean by that, that doesn't sound like a big deal, but suppose we had a program with hundreds of functions, and many of those functions expect a specific data structure like an array. Okay, and we are expecting an array of students because we've built this whole system like Blackboard that, you know, stores students, stores student grades, enrollment, all of that stuff. Now, let's suppose in the future that the structure, the format of that data changes. So now instead of wanting to use an array, we want to pass a vector because We want students to be able to change and dynamically update. Well, now what we'd have to do is all the functions that that were called or that expected an array would have to be updated. And it would take so much time and effort and programming salary to go through a procedural program and find every single little reference to the array and replace it with a vector. And so if we do object-oriented programming, then you just have to change it in one area, and then it's updated in the whole program. So object-oriented programming is really powerful. So let's talk about it, how that works and why it's such a big deal. It's all about abstraction. So what that means is as our program grows more and more complex, we need ways to deal with this complexity. So classes and objects are one way that we do that. Now, rather than thinking of like first name, last name, student ID, credit hours, and so forth, we can think in terms of the student and all of the details that come along with it. So not only operations like register, drop course, add course, those also come along with it. So it's not just the values of what a student could hold, like its name, but it's also the actions the student can perform. They're all bundled up together in a class. Okay, so if I had a student named Ben and it was an object and it was created from the student class, right? Because classes are a template and the objects are the instance of that class. So I have a student named Ben who's based off of the student class. He gets all of those attributes that we defined in the class template and all the methods and functions that we put into that student class. And I can register Ben, I can send or set his name, I can update his student ID, etc., all of that stuff. Now, you might think I can do all of that in procedural programming, how we've been working the entire semester, and you're right, we can, but what if now we need to figure out how a student is currently registered or something like this? Or what if the business logic changes? Then we need to figure out everywhere in the program where to update the code. Whereas if you have object-oriented, then you just have to update the method that is in the student class, right? So if you wanted to change name from a string to char or something like that, just to have the first initial, or just to use their student ID, you'd only have to change it in the class student, and then all of the objects that are created later on in your main would be updated. Whereas if we did it procedurally, then you'd have to, manually change every single logic in your code to update that. So object-oriented programming is not perfect, okay? It's usually really handy in larger programs, and it allows us to think at a higher level. So let's talk a little bit about encapsulation. Who knows what encapsulation is? What do you guys think encapsulation is? It's a fancy word. I know it sounds a little bit, scary, or really. Just gonna shut my curtain. Oh, it's getting really bright out. It sounds like something really advanced. Protection of data. Okay, yeah. So pretty much an object containing data or operations. So the fact that an object can contain data like values and properties and like a student can have a name and an ID, but also can have methods in it and operations that it can work on it. That's called encapsulation. So now that the data and the operations are all together in that class where they belong, and not spread across a ton of functions that are passing and receiving data, basically encapsulation is a mechanism used by object-oriented programming that helps us deal with complexity. So if you think about like capsules, right, or encapsulating something, you're putting it into like chunks or blocks. So we're putting, classes that contain data and operations, and this could be our student class, and then we could have another class over here for professors and another class over here for marks, and you're encapsulating all of those things, right? And it does have to do with protection of data a little bit, Raymond, you're right, because some things in the student class I need to only be accessible by the student, and I don't want other classes to be able to see or change the data inside of there. I only want the student to be able to do that. So it is a little bit related to that. But basically, it's the idea of encapsulation information hiding, that's kind of like what you're thinking of when you're saying protection of data. The basic concept is, you know, you have an object and inside of it there is properties and values and methods, and that's encapsulation. We can take that idea much further with what Raymond said with protection of data, and we can talk about information hiding. So what information hiding is, or what that allows us to do, is a feature of object-oriented programming where we can put specific implementation logic in our class so that it's only available within that class. And users of that class, trying to just read this, users of the class code to the interface since they don't need to know the implementation. So there's more abstraction that you use private and public modifiers, and it just makes it easy to test and debug, right? So if I make all of my variables private in the student class, and then stuff's only accessible through methods, then I know if something gets changed, then it must have been through that method. And it's not like I updated some global variable somewhere. And it makes it really easy to test because you only ever have to test the public modifiers, right? And we'll talk about this a little bit later, so don't worry if it's confusing. Information hiding is a helpful thing. And we know, say we have a public interface to a class of a user, and we know that the user of the class can't mess with the implementation specific code since they never knew about it in the first place. That's basically the concept. Cool. Reusability is another huge aspect of object-oriented programming. Obviously, if you make a class like a car or a student or a person and you want to reuse that in another program somewhere and it's already made, then you can just take that .cpp or .h file over to your new program and or just copy paste it and done. Since classes are pretty much little encapsulated units of data and the operations inside of them, you can build other applications much faster. Cool. So or I guess the last bit here, inheritance, which we'll talk about next week, and polymorphism, which this is kind of getting into, the more advanced C++ topics. We can create new classes in terms of existing classes. So, for example, I could have like a class of, how would I do this? Like what Bura said, I could have a class of creatures, okay? And that could be my top level class. And then from creatures, I could have a class that inherits all of the properties and values of creatures. So creatures might have, a height, a weight, and a name. Okay. And a creature can be anything. But then under creatures, I might have a class that says creatures extends from creatures, and it gets all of those things, height, weight, and name, but I call it water creatures, or amphibians extends creatures. So now amphibians all get a height, a weight, and a name, but then I can add custom properties to my amphibian class that extended its parent class. So it gets all of those things from the original class, and then you can customize it as well. So that's a really handy thing for object-oriented programming as well, and it's still part of reusability. Okay? Cool. Of an abstract example, but there is limitations with object-oriented programming, so it's not suitable for every scenario. Usually for smaller stuff, like even what we're doing it to learn the concept of it, but for the programs we're building, they're so small that it doesn't really make sense, right? Because it's actually a little bit more work for us. But if you were doing a big project for work and you had thousands of lines of code, you would want to split those up into multiple files and modularize it. Another limitation is not everything can easily decompose into a class structure. And it's not a fix-all solution. There's a steep learning curve to it. It takes lots of planning time and design to write a good object-oriented program. And sometimes they can be larger and slower and more complex. The good news for us is that C++ is probably the most efficient language out there. So for object-oriented programming, we're in a pretty good scenario to be in. Okay, so let's talk about classes and objects. A class is a blueprint. That's what I want you to think of it from now on. A class is a blueprint from which objects are created. Okay, blueprint, template, whatever word sticks for you and makes you remember that. So it's user-defined data type, so we can make it whatever we want. We can call it person, we can call it human, we can call it water animals, and it has attributes and methods, so data and functions. It can hide them, and it can provide public interface for us to access the hidden data. Examples would be like an account or an employee or an image, etc. STD vector and STD string are also examples of classes. An object is created from a class, okay? So remember that class is the blueprint or the template, and an object is created from it. It represents an instance of that class, and we can create as many as we want. So I could have a class called account, and then I can create, say I'm like a bank, okay, and I have a lot of customers. I can create account 1, account 2, account 3, or I can create accounts for Nike or accounts for Adidas, and we can create as many objects of that class account as we want. Each one has its own identity, and each can use the methods defined in the class template. So we could have an account for, Frank's bank account and Jim's bank account, and they each have their own balance, and they each can make deposits and withdrawals. And that's the power of object-oriented programming right there. So how do we declare a class, and how do we declare an object in C++? Okay, well, this one might be a little bit confusing, but the first example here, I know they're not classes, but it's sort of an analogy to help make a point, okay? So in the first two lines here, we're declaring two integers, high score and low score. And basically, what does this tell us? Well, these are variables. This is the variable name that is of type int. Again, integers are not classes, but just think for a moment, if an int was a class, then low score and high score would be an object created from that class, right? It would inherit all of the different properties that come along with it. Okay? They each have their own value, they each have their own identity. High score can be a different number than low score, but they each come from an int. Okay? So I know they're not classes. Don't think that they're classes. I'm not trying to confuse you here, but it's just to give you reference to the very similar way that we actually do create objects from classes. So down here, I've got a class called account, and I've created an object of account called Frank account and Jim account, okay? And these are instances of the account class, and they'll each have their own properties and methods from the account class. Now remember, vector and string, they're also classes, so we can make an instance or an object here, scores and name of the string and vector class. Okay, so how do we declare a class? Well, we have to use the keyword class followed by the name of the class we're declaring, and it's best practice to capitalize the first letter of our class names, of our user-defined class names. So if my class name was class_name, I capitalize C and N, and then put underscores in between the spaces. And then we have a block of code in these curly braces, or open and close, and then we can make any code logic in here. So we can declare properties, we can declare, we can declare functions that we want to be able to exist in this class, and they're going to all live within the body of this class declaration. So here's an example of declaring a class called player, and it would have the attributes of name, health, and XP, like experience. And we've declared the types just like we normally would, string, int, and they're inside this block code. And we do our attributes, and then we do our methods. So here's a method that returns void. It's called talk, and then we'd pass in a string called text to say. So if you did, player Ben, and I created an object called Ben that followed this template of player, then I would have to give it a name, some health, and experience, and then I could even call this method talk from the Ben object. Okay, and then we also have a Boolean object is dead, and it returns a Boolean, so 0 or 1 for 0 being dead and 1 being alive or something. Now, to create an object of that player class, then we just use the keyword of whatever we called our class, so capital P player, and then we give the object a name. So, Frank is a player, and we could also make Hero a player. And we can also make a pointer to a player object and use the new keyword that we talked about last week and create a player object on the heap, right? So instead of creating it on the stack, it actually would create it in memory on the heap, and we can dynamically allocate memory from our machine to create an object. But you remember, you have to use that delete keyword or else you have a memory leak afterwards. Okay, so the syntax should feel really similar since it's the same way we use primitive data types. And once you're finished with any pointer object like normal, we have to use that keyword delete. So just keep that in mind. Here's another example with an account class. So we use the class keyword, account with a capital A, any attributes, so name and balance, and then some methods, so withdraw and deposit, that return booleans. So if the withdrawal was successful, we could return a 1. If it was unsuccessful, we could return a 0. And then we could pass in the amount that we want to withdraw. Cool. So to create an object from account, we could create an account that is Jim underscore account or Frank underscore account. And you can create as many account objects as you want from the class template. And same thing, you can create a pointer to an account on the heap. But remember, you have to use that delete keyword. Cool. You can also treat it like any other type or variable, a class or an object that is. We can treat it like any other variable type in C++. So just like you can have a vector of ints or a vector of strings or a vector of doubles, we can have a vector of our object type. So our objects are, type account. So they're going to inherit all of the values from the account template or blueprint. So we can make a vector of that blueprint called accounts1 and pass it the accounts we made up here earlier. So we made Frank account and Jim account. Well, we can pass it Frank account, and then we can use the accounts1.pushback and pass it Jim account. Because it's a vector, we have that .pushback method, remember when we learned about vectors? And you can actually pass it a vector of the object of type account. You can also do an accounts array here with the square brackets and pass it to account objects as well. So remember that we can use objects in vectors and arrays. Very, very helpful. Okay, so I believe you guys understand how this goes, but I will do a quick example in CodeLite in the declare class and objects project here that I'll post onto our Blackboard. It's not on there currently. I'll just bring this over. Okay. So let's go through this. So here we have two classes. All right, so I have included my IOStream, string, and vector because I'm going to be using those, and I'm using namespace std. Now, my main method is down here on line 32, but before my main method, I've declared two classes. I've declared the class player with a capital P, and I've given it some attributes here. So I've given it a name, and I'm actually setting it, I'm initializing these to default values, which is kind of weird if you think about it, but you can set them to default values if we don't pass anything to it when we create our player class. And I'm also creating two methods, so talk and is dead. Now these are just prototype methods. There's no actual logic because I don't have curly braces with logic here. Now I can create logic. Same thing here on account. I've got an account name and a balance, as well as a prototype for deposit and withdraw. Okay, so how do we actually create an object of those classes? Well, you just use whatever you created your template name, so account with a capital A or player with a capital P, and then you can create your object name to be whatever you want. So I could have my account, I could have Jim's account, I could create a player that's called Ben, I could create a hero called Hero, and then I'd have to make sure that I reference, Ben everywhere in my code so that it works. And then we're doing this example here where we have a players array, right? It's of type player. It's called players, and we're adding two player objects to that array. Or we have a vector of type player object, and we pass it the Ben object, which is of type player, that class. And then we can do the player vec.pushback and pass it another player object here in hero. We also created a player called enemy, initialized it to null because you have to always initialize pointers to null. And then we can create it on the heap in dynamic memory using the new keyword, and then we just delete it here. So I can actually, I want to debug this. Right in here. Debug. There we go. Like to build and debug this. I'll show you what it looks like when we actually create a player in our debugger here. Okay. So I've got my debugger window. I'm actually going to drag it over here so it's a little bit easier to see. And I'm going to bring my watches down. Sheesh. Down to here. Okay, that's not letting me change that. We'll just stay here. Okay. So right now, not sure where that's come from. I can use these buttons to go next, 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 right? And which one do I want? Next, right there. And we'll create our Ben object on line 37. And check this out. We can see that this was updated. Name player health 100 XP3. I can also expand it with this little arrow here. And then we can kind of look at it like a JSON format, almost player 100, health 100, name player XP3. And we can see that those are the defaults that we set up here on lines 11, 12, and 13. So it's created an object named Ben, okay, and it has these values or these attributes of name player health 100 XP3. And then we can see here, we have enemy, hero, gym account, my account, all of these things. The hero and the enemy, they haven't been created yet, right? They're actually just going to be filled with garbage. Like this hero one, it's on the next line, so I haven't actually done it yet. If I expand this, look, the name is just filled with garbage. Health is 256 and the XP is 0. It's just filled with random junk because we haven't initialized anything. But if I hit the next button, you should see that stuff update here. I believe. Okay, so we made the array. Just going through, hitting next. Or maybe if I move this debugger down, stop it and we'll redo it. Start and continue debugger. Build and debug. And just to show you what it looks like. Oh, yeah, see, I didn't know why that got there. There we go. Build and debug. Okay, it's just taking a sec to load up here. And so we can see Ben's already been defined. Player health 100 XP3. And then enemy is 0 by 0 because it's set to null pointer. And if I keep going next through here, and if we look at the hero one, okay, let's expand this. So we can see that name is filled with junk, health is 256, and the XP is 0. If I hit next, that should initialize that object. And Oh, what the heck? It's not doing it. Player hero. It should. For some reason, my example is not working, but it does work on the Ben object. So that, oh, I know why. For some reason in locals, you have to hit this refresh button. And if I refresh this and then I expand my heroes again, you can see player 103. Now, for some reason, you have to hit the refresh button here on the locals panel in the debugger. If you're on watches and you add an expression to watch, and we just want to look at hero, okay, and we expand this, it updates automatically. So like if I stopped this program and then I rerun it again, it's good for you guys to know this because you might be confused like I just was, and you're like, oh, it's not updating. I don't know why it's not updating. But if I add this watch, okay, here, and I'm rerunning the program, we'll see that the watches panel is actually a little bit better at tracking stuff. So I can put in the hero name and I won't have to hit this refresh button here. So we can see there's the garbage data, health is 256 and XP is 0. If I hit the next button, I don't have to hit refresh. There, see? It updated. And now it's player 103. So just a handy little thing there to know as we're stepping through. You can look at your objects, you can look at the values and the properties and all of that stuff. So you might say, that's great. We can create a class, we can create an object. How do we access it? How do we get those values? If I wanted to print out the name of my player, how do I do that? Well, we have to be able to access class members. If we have an object of a class, then we use the dot operator, right? So here I've got an account called Frank account, and I just have to use my object name Frank underscore account and use that dot operator, and I can call dot balance or dot deposit. And those are the methods, and I can call those methods and pass values into them if they're expecting arguments, and we can access those class members. If we have a pointer to an object, okay, so like how we created the enemy pointer on the heap, then it's actually a little bit different. So because the dot operator has a higher precedence than the dereference operator, so the dot operator is obviously the dot here, and the dereference operator is the asterisk. Because the dot has a higher precedence, we have to put the whole dereference operator in brackets. So it's called first, and then that way it's dereferenced, and then you can call the methods. Or we can use something called the member of pointer operator, or a lot of people call it the arrow operator. And it looks like this. It does the exact same thing. It dereferences the object first and then calls the method. And it just looks like this. It's just a hyphen with an arrow, right, pointing to the method name balance. So it has the same effect as the first example. It dereferences the pointer and then applies the dot. Handy to know. Okay. So let's take a look at accessing class members. So I've got another example for you guys in this. In CodeLight, accessing class members, we'll set that to my active project, and I'll open the main.cpp. Okay, so accessing class members. So here we've got a class player, okay? And you'll notice this wasn't in the last example, this keyword public on line 9 and line 21 in both my account and player class. This isn't the best practice, but I'm doing it just for now, just so that we can access everything inside of the class, and I'm making it all public, okay? In the real world, you would make those private and then only have them accessible through getter and setter methods down here. But for now, I'm going to show you we make this public, and then we can access them later in our main. So I've got the same player class with name, health, and XP, and then I've got this void talk function. But this time, it's not a prototype, okay? It actually expects a string, and then it does some logic here in the curly braces. It coutts the name. So here's the name on line 11. And notice I haven't initialized it to anything this time. And then it says whatever the text to say was that's passed to that function when it's called. So let's take a look down here at what we've got going on in the main. So we also have the account class, which will take the balance plus equals the balance, or withdraw is minus equals the balance. So obviously it's going to either add or subtract money depending on if you're depositing or withdrawing. So here we've got an account called my account. I do myaccount.name and I can set it to, let's set it to Ben's account. Whoops. Ben's account. And let's set the original balance to $5,000. That'd be nice. Okay. And then we're going to deposit 1,000 and then withdraw 500. Okay. And then here I've got a player. I'm going to update this. I'm going to call the player Ben. And we'll keep it lowercase. Oh my goodness. The code light just crashed. Code light just crashed. Okay, let me just open that up again. Bear with me. I know. Please tell me it's opening. Goodness. Can you guys tell me, am I cutting in and out at all? Like my internet? Not sure. Okay, here it is. It's opening. No, I'm clear? Okay, good. I know I had some issues last week. I was looking at some of the recordings and my voice was a little choppy. It would chop in and out for about, 5-10 seconds. Okay, here we go. We've got accessing class modifiers. We'll bring this over and make that full screen. Okay. And open it up. Okay. So I'm setting, oh, whatever. We'll just leave it the way it is. I don't need to change the name. Okay, so then I've got a player called my. My.name is going to be Ben. I'll change my account as well. Ben's account. The health is 100, XP is 12, and I'm calling the talk function here. So look, I'm doing my, that's the object name, dot talk, and I'm passing the string. So what will happen is it's going to get that into the text to say variable and output it right here. So it should say whatever the name is says text to say. Well, what's my name? Well, I set it here on 42 to Ben. So it should say Ben says hi there. And then we've also created a pointer player, pointer enemy of player class. So it's an object here on the heap dynamically. And I set the name and it's dereferenced. Here it's dereferenced as well. But here I'm using the arrow operator to dereference it and set the XP. Then we can also call the talk method with the same, what do I call it, arrow operator or member of function operator. And we can pass this text to say right there. So let's go through this. We'll step through it. I'll put a breakpoint right here and we will open it up, the debugger, and kind of take a look at what this looks like. So build and debug. And I'll try to remember to hit the refresh button here, and then we'll have a little in-class exercise for you guys. Okay. And let me do this. I think this will be good. Stretch this over, this down. Okay, and then I will bring my console over just here in the corner. So we can see any text that comes out right there. Okay, so as we're stepping through this, okay, we're in account, my account. All of these are garbage, my enemy, my, and my account. Ignore the names. I know it's poor naming convention. But just for example of what creating classes looks like. So let's step through this one at a time. So we just created the my account. So name is, empty, balance is 0 because I don't have any defaults up here. So everything's going to be empty. Now, as I keep going, I just set the name to Ben's account. So now we can see it updated over here to Ben's account. And now watch, the balance is 0. If I hit the next on this line of code, line 35, my balance is now 5,000. Okay, so that's using the dot operator to access stuff from classes. Now I can call the deposit method, and let's check this out. It should put in 1,000. And let me just see where it goes up here. So it should bring us up to line 27 and deposit the balance, and then it'll also see out in deposit. So we should see something in our console here that says in deposit. So let's just hit next. I think it's thinking. Not sure what line I'm on. Wow, my computer is very, very slow today. What is also possible. Okay, there we go. I'll just hit next a couple times because I'm not sure where I am in the program right now. Seems to be a little bit behind. I'm gonna maximize my console. Ah, that is what happened. Okay, so we couldn't see it. Let me run this again. We couldn't see it because the sizing of my console, it wasn't showing. So that was a bad example, but let me just load this up again. Debugger, start and continue debugger, and build and debug. Okay. And then I'll bring my console over. Right there. And I would like to pick code light. There we go. And then I will just change the sizing. Okay. So let's hit next a couple times. Set the name of our account to Ben's account, and we'll set the balance to 5,000. So we can see those updating on the right-hand side right here in the debugger. All right, and then we will go down to the deposit method and deposit 1,000 and check that out. Now balance says 6,000. And if I go to my console here, we can see, okay, it says in deposit there. So we know that it outed that correctly. I'll just move it here. And now we're going to go to the withdraw. So we're going to take out 500. So this should go to 5,500. So we'll click this, and it should also say in withdraw. So it did. So that is this method being called, the withdraw function. And look, we're at 5,500. Perfect. Now we're going to create a player object from the player class called my, because I couldn't change it to Ben. So if we take a look at the my object, we can see it's just garbage data in there. If we keep clicking next through these, we're accessing these class members, and we're going to set the name to Ben, the health to 100, and the XP to 12. And I'll just hit the refresh button here because we need to on that object, and there it is. So there's Ben, health 100, and XP 12. And then I'm going to call the talk function, and that should print something in the cout, and it should say Ben says hi there. So let's try that. And there it is on the console. On the right-hand side, it says Ben says hi there. So that's how we access stuff in a class. And then you can also do it with a pointer here. So we'll create a player object called enemy. And we can see enemy is just initialized to whatever address in memory. Okay, so 0x1f4220, that's the address in memory that my player object's stored on the heap. Now I've dereferenced it and set the name to enemy, the health to 100, and the XP to 15. And I will just refresh this so that you guys can see that is actually what happened. So there's the address here is enemy 115. And then we can actually call an object that's created on the heap from a pointer using that arrow function method and pass I will destroy you to the talk method. And there it says enemy says I will destroy you. Perfect. So that works the way we want it to. And then obviously you'd want to call delete enemy there. Otherwise, there's a little memory leak if we keep running our program. So I'll just stop that there. I'm going to go back to the PowerPoint and I'm going to give you guys a little class exercise, in-class exercise to work on here. I'll turn off the recording. We'll take a 10-minute break, whatever. But I want you guys to use the code below here. So just include string class dog public std string name int age. Okay, so it's a class of dog. And I want you to create a C++ class named dog that will be located in dog.h. Remember what we covered in header files. And then in the main method, import dog.h and write a test dog function. So you want to create a dog object named spot and then use the dot operator. So do dog.name equals spot and then set the name attribute to the string spot and the age attribute to 5. Okay, you can do it in one file. You don't have to do it in the header file. If you remember how we did header files a long time ago, then you can do it in the header file. We're going to talk about how to do it in header files later today, just to kind of remind you how we did it. So if you want to do it in the same file, like how I just showed you in that example, do it in the same file and call it from the main. If you want to do it in the header file, then do it in the header file, and then we'll kind of take it up together as a class. I'll end this recording here. Any questions before we do this little in-class activity? No? All good?